all. So we are virtual today and Tuesday and Wednesday, but I wanted you to be able to have an explanation that you can jump around to from problem to problem if you want to hear something with the review. I'm going to work through the marking period 2 quarter exam review sheet A, and then you can apply the same principles to B. This covers pretty much all of the problems on the marking period exam except for the stuff in section 1.6. I think I'm uploading this to YouTube, and if I do, I'm going to try and have timestamps up in the corner that you can jump to whichever problem you need. So, problem number 1 is following the power rule. We have 3x to the negative 2y over negative 2y to the negative second, all raised to the negative third power. So remember, when you're following the power rule, this power of negative 3 on the outside gets distributed to everything. So what this equals is going to be 3 raised to the negative third x, and because you're raising a power to a power, remember, x squared raised to the third is the same thing as x squared times x squared times x squared, which is going to equal x to the sixth. X to the sixth, not 6. So what you're doing is you're multiplying the exponent. So this is going to become x to the negative second times negative third power. And this is going to be y to the negative third, because it's y to the first. This is all going to be over negative 2 raised to the negative third, and then y to the negative second times negative 3. Be careful when you're doing this negative 2 to the negative third power. It's that whole entity of negative 2. It's not just negative and then 2 to the negative third power. It's negative 2 to the negative third power. So what I do next is my constants, I flip them over the division bar, and I keep the power. So 3 will go to the bottom, and it'll just become 3 to the third, and negative 2 will go to the numerator and go to the third. And then I simplify my exponents. Negative 2 times negative 3 is x to the sixth, and we're going to have y to the sixth in the denominator, and I'm going to keep my y to the negative third in the numerator. And we work this through. 2 to the negative third is negative 8. 3 to the third is 27. X to the sixth, x is the only power here. You can do this in 2 steps if you want, because just a note here to the side. To find what y is, you take y to the negative third, since it's division, minus 6, which is the same thing as y to the negative third plus negative 6, which is y to the negative ninth. And y to the ninth is the same thing as 1 over y to the ninth. What I do personally is I subtract them and say, okay, negative 6 minus negative 3 is y to the ninth. So, I mean, you can do it in your head. The better you get at it, if you want to work it out, that's how it works out. That's the end of problem 1. Problem 2, it'll say to simplify. So you have 12 over the square root of 10 minus 2. Remember, you cannot leave a radical in the denominator. That is just a big no-no. And what you want to do is you want to multiply through by the denominator, not 12 times 10 minus root 2. It's going to be 10 root 10 plus 2 over root 10 plus 2. You have to keep, remember, you're going to swap the sign, and you're going to multiply by root 10 over 2 over 10 root 10 plus 2, because it's a unit of 1, so we're not changing the value. When you do that, you get 12 times root 10 plus 2 over root 10 minus 2, root 10 plus 2. Distributing the 12 gives 12 root 10 plus 24. The square root of 10 times the square root of 10 is the square root of 100 plus 2 root 10 minus 2 root 10 minus 4. These middle terms will cancel out. So you're left with 12 root 10 plus 24. The square root of 100 is 10 minus 4. Remember, the square root of 10 times the square root of 10 is just going to equal 10. Square root of x times the square root of x is just x. Root 3 times root 3 is just 3. And we keep going. 12 root 10 plus 24 over 6. And then you want to simplify it a little bit more. So it's 12 root 10 over 6 plus 24 over 6. If you get to the point that we were just at above and your answer isn't in the multiple choice, keep simplifying. This becomes 2 root 10 plus 4. And that's your answer for number 2. Problem number 3. You have 24 divided by 3 root 12. Again, this is just, you can't have radicals in the denominator, so you want to multiply by a unit of 1. Root 12, root 12. And when you do that, you get 24 root 12 over 3 times, well, the square root of 12 times the square root of 12 is 12. When you go through this, you get 24 root 12 over 36. Now be careful, the square root of 12 does simplify a little bit more. Equals root 4 times root 3, which is 2 root 3. That's one way to do the radicals. Second way to do the radical, say, okay, 12 factors out into, say, 6 and 2. 2 doesn't simplify anymore. But 6 simplifies to 3 and 2. So I'm going to pull a 2 out of there. And what's left underlined stays in the radical. So there's 2 different ways you can look at this to get the same answer. Find whichever one works better for you. Either way, this becomes 24 times 2 root 3 over 36. 24 times 2 is 48. Root 3 over 36. 48 over 36 can be simplified because they share a common factor of 12 to 4 root 3 over 3. And that's your final answer. Number 4, again, more power rule. We're taking the cubed root of negative 27, x to the 6, y to the 12th. Remember, a shortcut when you're dealing with variables is take this index number and divide it into whatever your exponent is for the variable. So 3 goes into 6 2 times. 3 goes into 12 4 times. So we're looking for something that's like x squared y to the 4th. But if you work this out, remember you can separate these by using the power rule. The cubed root of negative 27 times the cubed root of x to the 6th times the cubed root of y to the 12th. Anytime you see a cubed root of a negative number, I always told you pull the negative out first. Say the negative cubed root of 27, cubed root of x to the 6th. I'm going to do it all in one step. What's the cubed root of 27? Do that in your calculator. Pull it out if you need to. And you can really do this with negative 27 too. If you pull out your calculator and you go to math, and then number 4 is cubed root, put in negative 27, close the parentheses, it's going to tell you it's negative 3. You can use calculators. I encourage you to use calculators. Really learn how that works. So cube root of negative 27 is going to be negative 3. Cube root of x to the 6th is x squared. Cube root of y to the 12th is y to the 4th. Because remember, we're looking to find a pair of 3, which would be y to the 4th, y to the 4th, y to the 4th. And this would be x squared, x squared, x squared. So right there, there's your answer. Calculators are your friend. Number 5, x minus 2 root 3 times x plus 2 root 3. This is a difference of squares. So we're a minus b times a plus b equals a squared minus b squared. So if we apply that here, we're going to have, it's going to equal, all right, a squared minus b squared again. Since our a is the same thing as x, this is going to become x squared minus our b is 2 root 3 squared, which means it's x squared minus 2 root 3 times 2 root 3, x squared minus 4 root 3 times root 3 is going to be 3, x squared minus 12. Number 6 is where the problems start getting a little bit longer. So it's x squared minus 5x minus 6 divided by x squared plus 7x plus 6 minus 1 over x plus 6. This may or may not be an open-ended problem where you're going to have to do the restrictions. That's what they're called. So step 1, you're changing your subtraction to addition. I'm going to do that on the initial problem because for me that makes more sense. And then you want to factor out the denominators. So we get x squared minus 5x minus 6 over, I'm just copying the rest of the stuff over, x squared plus 7x plus 6 is going to factor out into x plus 6 and x plus 1. So our LCD is going to be x plus 6 times x plus 1. Meaning we don't have to change anything in this first expression because it has a denominator of x plus 6 over x plus 1. Or it's over x plus 6, x plus 1. So we just want to bring that down. And then this one over here to the right, we're going to have plus negative 1. It's already over x plus 6. So we need to multiply through by x plus 1 over x plus 1. And then from here, now we can write everything over the same common denominator of x plus 6, x plus 1. And we have x squared minus 5x minus 6 minus 1 times x plus 1. Simplifying a little bit more, minus x minus 1. Now combining our like terms in the numerator, and I'm working this out with a lot more steps than I have on my paper, but this is going to become x squared. And here's our common terms. We have negative 5x minus x. Negative 5x minus x is going to be negative 6x. Negative 6 minus 1 is going to be negative 7 over x plus 6, x plus 1. As is tradition, there's not enough space. Now we're going to factor our numerator. Rewriting the denominator. X squared minus 6x minus 7. We're looking for factors of negative 7 that add up to negative 6. Well, that would be negative 7 and positive 1. Our x plus 1 are now factors. Remember, you can cancel factors. You cannot cancel terms. You can't cancel any earlier than this. So our final answer is going to be x minus 7 over x plus 6 with a restriction. And in our denominators, we look up here, back at the circled problem here. Our denominator cannot be negative 6 or negative 1. So number 6 was a bit of a long one. Number 7, a little bit worse than that, but not too bad. So remember, you want to set restrictions on this, and this when you're doing division. When it's multiplication, you just put on all the denominators. So step 1, invert. To b squared plus 13b plus 42 over b squared plus 5b minus 14. I'm going to change my division to multiplication and flip or invert the second fraction. And now, because this is division, we want to factor everything. So factors of positive 42 that add up to 13. Well, let's try b. Factors of 42, 7 and 6, they work. So b plus 7, b plus 6. Factors of negative 14 that add up to positive 5. So it's going to be a positive and a negative. Well, 14 is negative, 5 is positive, so our bigger number is going to be positive. Let's try 7 and 2. Positive 7, negative 2, that works. Now we're multiplying by factors of negative 10 that add up to negative 7. Well, that's going to mean both of those are negative. 5 and 2. And b squared minus 36 is a difference of squares. This will be b plus 6, b minus 6. I'm doing my best to try to make my b's and 6's look differently. If they don't, I am terribly sorry, but I've tried my best. So now I'm going to cross cancel, and I'm going to keep my same terms that I'm canceling out with the same color. So starting on the left, I have b plus 7, they cancel out. Let's do orange. See, I have a b plus 6 here. That's going to cancel with this b plus 6 here. I have a b minus 5. I do not have a b minus 5, but I do have a b minus 2 and a b minus 2. Meaning what's left is b minus 5 over b minus 6. And remember, I just set restrictions on each of my denominators, so on each of my terms. So I'm going to highlight everything in pink that has to have a restriction. So remember, it's everything in the second fraction. That's my b minus 5, b minus 2, b minus 6, b plus 6. And then anything in the numerator that wasn't covered. B minus 2 is covered in the green. B plus 7. So your final answer, the restrictions, since these are all pretty easy to do, is going to be B cannot equal negative 7, positive 5, positive 2, negative 6, positive 6. Looked uglier than it was. I left a lot of room for that one because I thought it would go for longer than that. And that is the first 7 problems. I'm going to do a separate video for the back 8 problems. partly because I'm running out of time, partly because I don't want this to be super duper long. So that's the end of the front sheet. I will have the second sheet posted in Google Classroom as well. Take care.